Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdiana binti Muhammad Masha. My matric number is 2313228 and from Agricultural Systems. In this video, I will explain my recommendation on selecting the most suitable material for spacecraft application using engineering economic analysis. A metallurgical engineer is considering material X and material Y, and the decision is based on present worth and annual worth analysis at an interest rate of 12% over a 5 years life cycle. This decision is important because in aerospace engineering, cost efficiency, safety, and sustainability are all closely linked. A raw material choice does not only affect cost, but may also impact mission reliability and responsible use of limited resources. Both materials have the same service life of 5 years, but their costs are different. For material X has a lower initial cost of 15,000 but higher annual maintenance cost which is 9,000, a relatively low salvage value of 2,000. Meanwhile, for material Y has a much higher initial cost which is 35,000 but lower annual maintenance cost which is 7,000, a high salvage value of 20,000. To compare them fairly, I use present worth and annual worth method which consider the time value of money. So, first thing first, I conducted the present worth analysis at an interest rate of 12%. Present worth convert all future costs and salvage value into their equivalent value today. This allows us to compare both material on a common financial basis. After calculating, the present worth of material X is approximately 46,308 ringgit. Meanwhile, for the present worth of material Y is approximately 48,885 ringgit. Since both alternatives represent costs, the material with the lower present worth is preferred. Based on this analysis, material X has a lower total life cycle cost, making it the better option economically. So, I will put the calculation here. So, next, I perform the annual worth analysis, which convert the total life cycle cost into an equivalent uniform annual cost. This method is useful for understanding how much each material effectively costs per year over its service life. The results are material X has an annual worth of about 12,846 ringgit per year. Meanwhile, for the material Y has an annual worth of about 13,561 ringgit per year. Again, because we are comparing costs, the lower annual worth indicates the better choice. Both the present worth and annual worth analysis consistently show the material X is more economical. So, I will show the calculation here. Based on both economic evaluation method, I strongly recommend material X. Even though material X has a higher maintenance cost, its much lower initial cost make it more cost effective over the 5-year period. This decision reflects good engineering judgment, where cost efficiency is balanced with long-term planning. Choosing material X allows aerospace projects to operate within budget while still meeting functional requirements. So, choosing the wrong material, such as material Y, can lead to several negative consequences. From a cost perspective, material Y results in higher overall life cycle costs. This means more money is spent than necessary, which is critical in aerospace projects where budgets are limited. From a safety perspective, overspending on materials may reduce funds available for safety testing, system redundancy, quality control, and maintenance. In aerospace engineering, poor financial decisions can indirectly compromise safety and mission reliability. Therefore, selecting a cost-inefficient material is not just a financial issue, but a potential risk to mission success. For aerospace engineering requires responsible and sustainable use of resources. By choosing Material X, we can minimize unnecessary expenditure, use financial resources more efficiently, allow budget reallocation to innovation, safety improvements, and future missions. Sustainable engineering is not only about environmental impact, but also about economic sustainability. A cost-effective choice ensures that projects remain viable in the long term and that limited aerospace resources are used wisely. In conclusion, based on present worth and annual worth analysis at 12% interest rate, Material X is the most suitable choice. It offers lower total life cycle costs, better annual cost efficiency, more responsible use of limited aerospace resources. Therefore, Material X is the better option from an economic, safety, and sustainability perspective. So, that's all from me. Thank you.